Good afternoon, students. Today we will discuss about stereoisomerism exhibited in coordination compounds. Already we know what is isomerism. Same molecular formula but different placement of the atoms or ligands is called isomers. And here same molecular formula but different spatial arrangement of atoms is called stereoisomerism. That is in 3D form. The 3D form, the ligands attached to the central metal atom will be differ. Here, similar if the similar groups are adjacent to each other, that is nearer to each other means that is comes under cis isomerism. And if the similar groups opposite to each other means it will be comes under trans isomers. That is A is diagonal to A. Here this is trans isomer. Here these two similar ligands are adjacent to each other. Here the similar ligands are opposite or diagonal to each other. Okay, in coordination compounds, the possible isomers are formed from coordination number 2 to 9. In geometrical isomers are not possible in the case of coordination 2 and 3. Because the same groups are adjacent to each other. And in 4 coordination number we will discuss about the geometrical isomerism in 4 coordination and 6 coordination number. Now we will concentrate about 4 coordination number geometrical isomerism. Here in this case these three type Ma to B2, that is metal A to B2 and metal A to BC, metal ABCD. Here the ligand, two similar ligands will be same. So totally 4 ligands. Here one ligand will be same and third one and fourth one will be differ. And here all the 4 ligands will be differ. See, when the metal is coordinated with all the 4 ligands, two groups of ligands are there, Ma2 and B2. If they are adjacent to each other means cis, and if they are diagonal to each other or opposite to each other means trans. Here some examples are given. Here platinum is the central metal atom. It is Cl2, A2, B2, that is metal A2, B2 type. Again these two also the same pattern. In the place of this part, cis and trans part, you have to just replace the central metal atom, and in the place of A replace with chlorine, and in the place of B replace with amine ligand. Here again central metal atom will be palladium, and in A place nitro group is there, and in the B place amine group is there. Here in this case platinum is the central metal atom and chlorine is the present in A place, and pyridine is the placed in B place. Okay, and in Ma to BC type, platinum is the central metal atom, and in the place of A pyridine is there, and B is amine and C is chloroligand. Here again when A that is the similar groups are adjacent to each other means that is cis, and when the similar atoms or groups are opposite to each other means that is comes under trans. In MABCD type we are getting 3 isomer with respect to one ligand. If we are keeping one ligand as constant means that is we are fixing the one end and we are rotating all the 3 ligands means we will get 3 different isomers. So with respect to A, C is diagonal to okay, so we are getting one trans isomer. Here with respect to A, B is diagonal to A, so we are getting another one. And in the case of here with respect to A, D is diagonal to A, so we are getting this isomer. For this one example is given, platinum is the central metal atom and nitro group, pyridine C2H5N, pyridine you can use Py also. Here amine and hydroxide. Here we will keep any one of the ligand. You just try of your own. Now we are keeping NH2OH as the fixed one. By fixing this, we can place the other three ligands. So here NH3 is diagonal to NH2OH. So we are getting trans NH2OH and NH3. Here with respect to NH2OH, pyridine is diagonal to it. So we are getting another isomer form. Here with respect to NH2OH, NO2 is placed diagonal to it. So we are getting another isomer. So you try with some other ligand. For example, if you are keeping amine with amine as the fixed one, means you can change all these three ligands. Okay, you try over it. And in this case of monodentate ligand, they in for coordination number in MA4 type and MA3B type and MAB3 type, the number of ligands are adjacent to each other. So it is a 4 coordinate complex. More than 2 ligands are available. So every ligand will be adjacent to each other. That is, all possible spatial arrangements will be exactly equal. So here only cis form is possible, not the trans form. And in the case of bidentate ligand, two different donor atoms are present, means it will comes under unsymmetrical bidentate. Unsymmetrical means different, and symmetrical means same. Same means the donor atoms will be same. Okay, for example, in oxalate, oxygen is the donor atom. 2 oxygen atom is the donor atom. See here, MAA twice. Here in the case of oxalate, 2 oxygen atoms are just the donor atom. Here in the case of ethylene diamine, we are getting 2 nitrogen atoms as the donor atom. So similar atoms acts as the donor. So it is comes under symmetrical bidentate. 2 donor atoms are there. So symmetrical, same bidentate. 2 ligands are there. So same 2 ligands present in the ligand. So 2 donor atoms. So symmetrical bidentate ligand. Here in this case, diglycinate platinum 2. See here, NH2 CH2 COO minus. One oxygen is being as the donor and one nitrogen is being as the donor atom. So it is unsymmetrical. 2 different atoms are being as the donor atom. So it is comes under unsymmetrical bidentate ligand. Here the nitrogen and oxygen being the donor atom in one ligand, and here again one nitrogen and oxygen as being as the donor atom to the central metal atom, but the nitrogen and nitrogen are adjacent to each other. So it is comes under cis isomerism. Here in this case, again the same glycinate ligand is attached to the central metal atom. So nitrogen and nitrogen is diagonally placed. So it is comes under trans isomer. Even you can consider this oxygen also. So NH2CH2COO minus, NH2CH2COO minus. In the case of tetrahedral, the metal will bonded with 4 different ligands. One will be the above the plane and other 3 will be the below the plane. So what will happen? These 3 will be these three will be adjacent to each other, so here cis isomer only possible. In the from the book I have given in simple form, just go through it. Cis form means adjacent to one another, trans means opposite to one another, so it is referred as cis and trans isomers. And most familiar coordination compounds are formed from 2 to 9, but there is not possible to get geometrical isomers for coordination number 2 and 3, and 4 and 6 coordination compounds are very familiar. The 4 coordination compounds exhibits geometrical isomerism. When similar atoms are attached to each other, we will get cis form, and when it is diagonal to each other, we are getting trans isomer. See, the examples are given. In the place of A and B, the ligands are substituted. Okay, and the second type, Ma to Bc type. See, M metal, A, B, C. Examples given here. So you just substitute and see. Here in the case of MABCD, metal AB, metal AC and metal AD, both are identical. Anyway, if you are substituting the ligand in any way, we are getting AD format, that is trans AD and BC. See here, trans BC. Okay, example is given here. By fixing NH2OH, the other ligands are shuffled. Okay, here in this case, geometrical isomerism for coordination compound in Ma4 type and Ma3B3, Ma3B and MAB3 is not possible because similar atoms will be arranged in adjacent places. And in bidentate ligand, NH2CH2COO. Okay, here nitrogen and nitrogen, oxygen and oxygen are adjacent to each other, so cis form. Here in this case, nitrogen and nitrogen, oxygen and oxygen are placed in opposite to or diagonal to each other, so we are getting transform. Okay, geometrical isomerism exhibited in coordination compounds will be discussed in next class. Thank you, girls.